Okay, welcome back. This video is kind of part 2 of some literal equation solving. We're just going to do 4 examples and drive home a couple points, give us some more practice. So feel free to start with this one, pause the video and try to solve it. This is k equals 1/2 mv squared. Solve for v. All right. And I'm going to multiply both sides by 2 first, then divide by m. Take the square root of both sides and end up with v. And mathematically speaking, right, we need to have plus and minus for that radical. And some values, depending on the physical situation, some values will and can be positive or negative values describing a physical situation. Other types of values cannot. They can always only be positive, for example. So we will encounter those, generally speaking, different types of quantities like that next week. But just be mindful, sometimes we need that plus or minus, sometimes it can only be plus or minus. Second example here we'll look at, let's say we have an equation like we had from last time. V squared equals v naught squared plus 2a delta x. But I'm saying let's solve for a this time, but let's pretend like we know that delta x, like I said, we treat as one variable when we're solving. But let's say we know what the values are that make up that difference in x, namely x minus x naught, or x0. So I can substitute that value for delta x in, as I have done, and I need to have my parentheses there to indicate that this is a particular value for delta x, and it is found by subtracting the initial x quantity, x naught or x0, from the final x quantity, x. Just like we would do with our slope equation, delta y over delta x, or y2 minus y1, final y minus initial y. All right, same sort of thing when we write delta x here. It could stand for position or something else, but there we have delta x separated out into its difference. I'll divide both sides by x minus x naught. Then I'll divide by 2, because I'm taking every step possible, and finally solving for a. Okay, make sure we have done that subtraction first of v naught squared onto the other side of our equation. Another example, we're going to look at F sub g, the force of gravitation, equals big G times m1 times m2 divided by r squared. Solve for r. So one way I can rewrite this is, as I've done in the second line there, F sub g equals big G times m1 m2 over 1, it's like its own fraction there, times 1 over r squared. Sometimes that's helpful, pull those fractions apart, as long as you're not breaking any rules. Pull a fraction apart so you can maybe help organize those variables if you need to. Okay, then on the third line I've put them back together partly. F sub g equals big G times m1 times m2, all that divided by 1 times 1 over r squared. You see I'm kind of separating it out where I can just focus on my r that I'm looking for. And what am I going to do next? I can multiply by the reciprocal there to get my larger fraction over there onto the left side. So now I have f sub g divided by gm1 m2 equals 1 over r squared. And I'm looking for r. So like one of the examples from last time, I'm going to take both sides of the equation to the -1 power. I get the left side flipped and the right side flipped, and I have r squared over 1, and then I need to take the square root again. And I'm mindful of that mathematical property of having a positive or negative root, and that can be squared to produce a positive squared value. And so I have plus or minus the square root of big G times m1 m2 divided by f sub g. Maybe there's a good point to say also that the capitalization matters, very much so. Just like f sub g is f with a little g subscript, is not the same thing as f times lowercase g. All right, I'm trying to be clear that that's a subscript. That should look like a subscript the way I've drawn f sub g. If I drew it to be multiplied together, it would look like f times little g, like they'd be right there on the same line, not in a subscript. Okay, so this is the subscript f sub g. That's very important to recognize that it's a subscript, and this is a package deal. This is one variable right there. All right, and the capitalization, capital G, big G, stands for something else. That's a completely different variable, big G. And in the next one we'll have a little g variable. These are different things. Okay. Number 4 example. Now this one we're looking for little g. And this equation you might remember from last year maybe, but I'm going to, looks like I have a typo there, looks like I need a 2 pi. Let's throw that in there. Okay, I'm dividing both sides by 2 pi in order to begin to solve for g. Oh, I did write it. And then I have t over 2 pi equals square root L over g. And I want to get to my g, so I've decided to square both sides. That removes my radical. And notice my square, my exponent, distributes on that denominator, so it's 2 squared times pi squared. So I have t squared divided by 4 pi squared equals L over g. So that radical's gone away. I'm looking for g, not its reciprocal, so I will negative 1 power that thing, and I get 4 pi squared over t squared equals g over L, because it's flipped. And then multiply both sides by L to isolate g, and I put a box around my final answer. 4 pi squared L over t squared. That's about it for our examples there. Like I said last time, let's add a new slide and let's say, like I said last time, expect a quiz on Friday, which is tomorrow, the 18th, I think. Pretty sure that's the 18th. And expect to have on there, as we've, stuff we've practiced in class, stuff we've been doing, a lot of math review, but be able to manipulate these literal equations that we've done some examples of now. We want to be able to look at what else? Our basic and inverse trig functions. Okay, you should be able to find the value of a side of a triangle or the angle depending on what we're doing. Basic, inverse trig functions, which means you need a scientific calculator, a calculator that has a sine, cosine, tangent, and the inverse functions built in. And I should be able to plot, graph, and linear fit data manually. Okay, I'm not going to quiz you on using your calculator or your Desmos app or whatever yet. Those are generally easier to do than manually finding the stuff, so make sure you're able to do all of those things. I'm looking for literal equations, basic and inverse trig functions, and are we able to plot data, find a line of best fit? Can we find the slope on that line of best fit properly? That means using what? The lines on, or the points on the line, not data points, and be able to write out that full linear equation. That means in the form of y equals mx or ax plus b. Okay? And remember, we find that slope the way we talked about, using points on the line, and most of the time you have to estimate your b. Okay? So you should be able to do a good estimate if you have a nice scaled graph. All right. That's it. See you tomorrow.